Here is a specific heat capacity problem that is very much like the lab that we did in class, where we have a sample of a metal. In this case, it is tin, and so we know the mass of the tin is 0.225 kilograms. And we are going to heat that, and in class we heated that by putting it in boiling water. So we took this block of tin and we heated it up using a Bunsen burner. And so the temperature it reached to start, so the temperature of the tin initial is 97.5 degrees Celsius. Okay, then we took that tin and we dropped it into, so we transferred it out of the hot water and we put it into the styrofoam cup of cold water. And so the heat from the tin that we had just heated should transfer to this cold water. This mass is 0.115 kilograms, and it starts with an initial temperature of 10. Okay, and so we heat transfers, heat leaves the hot tin to the cold water, hot tin to the cold water, hot tin to the cold water. Actually, it was covered up by the water. Hot tin to the cold water, and so it reaches what is a final or an equilibrium temperature of both objects of 18.5 degrees Celsius. We know that energy cannot be created or destroyed, and so the heat lost by the tin must be equal to the heat gained by the water. And the amount of heat transferred is dependent on the mass of each substance, the specific heat capacity, and the temperature change it goes through. Same thing for the water. So if I know the mass of my tin is 0.225, I'm looking for the specific heat capacity of the tin. That's what my final answer is. And the temperature change it went through, I can either do the subtraction in this equation here, or I can do it separate and say the temperature change the tin went through was a final of 18.5 minus the initial of 97.5, which is a negative 79 degrees Celsius. So I can put that in here. And then that is equal to the heat that the water gained. Water's mass is 0.115 kilograms. Water's specific heat capacity is 4186 joules per kilogram times degrees Celsius. Super important that these units match the units of all of your other variables. So mass has to be in kilograms, heat will be in joules on both sides, and your temperature changes have to be in Celsius. And so the temperature change the water went through, again, had a final of 18.5. This was the tin. This is the water. Final temperature of 18.5, an initial of 10.0. So that's a change of positive 18.5 degrees Celsius. So this is 8.5 degrees Celsius. And so my Celsius units cancel, my kilograms units cancel, and I should end up with the same units on this side, which is kilograms degrees Celsius. And this specific heat capacity has to be in the same units, joules per kilogram times degrees Celsius. So when I solve for C, I get 232 sig figs, actually 3 sig figs, joules per kilogram times degrees Celsius is the specific heat capacity of the tin. That means it takes 230 joules to raise 1 kilogram of tin by 1 degree Celsius.